Okay. Last time we were going through our homework assignment, and towards the end of class, we were dealing with our process expression code. So we hopefully kind of got an appreciation for the benefit of breaking problems down into smaller pieces. If you try to solve the big problem right away, you're going to start having problems pretty quickly. So in the end, it shouldn't have necessarily seemed easy, but each individual part we solved should have felt easier. Make sense? Go ahead. Should have felt easier. So now we're going to start transitioning towards making our own objects. So up to this point, all the functions we've made have always been static. I've kind of promised you we're going to talk about what it means to be a static, or why we would create a static method versus a non-static method. And now we're going to start having the opportunity to do that. So what we're going to do here is we're going to go ahead. I'm going to create a brand new project. Now, first of all, just as a reminder, last semester we talked about the difference between object-oriented and procedural languages, right? We used the telephone as our example. Okay, so the idea there, and so we're going to actually write code that exemplifies this idea now. So the idea was that the procedural telephone has all of our wires exposed to us, all in one big pile. Both the public and private parts of it are just sitting there on the screen, but we only accessed the public interface. Make sense? So we have a whole bunch of crap here on this one screen. All these details that we wrote, it works, we're happy with it, but now we don't need to mess with it. We just need to have access to it, and we access it through this process expression right now. All right? So very much, even though Java is an object-oriented language, up to this point we've been using it as a procedural language. We've been writing very much procedural code, putting all of our crap in one big file. All right? So now we want to look at the better way of doing it. Yeah, let's say better way of doing it. The object-oriented way of doing it. So I'm going to go up here. I'm going to say File, New Project. And actually, let me cancel this real quick. We're going to do New Java project. File, New Java Project. You could have done that from the project window, but this is better. All right. We're going to call this guy Dice Roller. All right, Dice Roller. How many of you have ever played, well, I'll start with Dungeons and Dragons, tabletop role-playing type stuff. I was a big, 2 people? Three. Okay, other games like that. Yeah, so I used to be huge into tabletop role-playing stuff. I used to go to different big conferences. There used to be a conference called Origins. I don't even know if it's still around, but I would be a dungeon master pro guy who would like run the campaigns, and yeah, super nerd stuff. This was back in the days when you had these dudes who were dressed up as wizards, sitting there playing some game with dice and stuff for like 17 straight hours, and you thought those were the cool guys. So, yeah. But in any case, we've all played games that involve dice, right? Okay, the reason I bring up Dungeons and Dragons, and it's a good example of a game that uses a whole bunch of different combinations of dice, right? You know, so you might roll a 20-sided die to find out if you can attack somebody or hit somebody. You might roll a couple of D6s, 6-sided dice for rolling your damage. You might roll a D8 or a D4. You know, all these different dice are becoming involved in the game. Okay, so punchline for us is it would be good if we had a tool that allowed us to generate various dice. Because if you're a Dungeons and Dragons player, you know, you go and get the dice sets, right? So a couple people, so you have dice sets. Okay, how many dice do you have?
Well, I got one set that's got a D20, and then a couple of D3s and a couple of D10s. And then I've got this large package that has probably about 30 single D6s.
Okay. So let's see. Are you a relative beginner to D&D?
Yeah, I haven't had too many opportunities to play.
Okay.
Mostly I actually use it for keeping counters in Magic.
Okay. All right. Magic player. All right. So yeah, I used to be a big Magic player. Then I had I played since day one, so I had some really expensive cards. Sold all those, and I just play Hearthstone. Um, uh, what's your dice situation?
I just have like one set of each.
Oh, so you're like a noob.
Pretty much. I don't play anymore. I just play nice skills.
Oh, I gotcha. So I had monster, like, garbage bag of dice. All right, monster garbage bag of dice. So I'm going to tell you a little story that hopefully kind of excites you about computer science a little bit. You know, I don't know, there's probably 100 D20s in there. You know, just the collections of dice from, you know, playing this for years and years and years and years. And, you know, I still actually will occasionally play Dungeons and Dragons with some students and stuff. We have a couple of computer science students who still run campaigns. But I always do quirky role-playing stuff. Like, I don't know, like one campaign I was in, I had a halfling monk who was, he assumed he was royalty, but he actually had slave tattoos. I had a wizard who refused to use magic. So I come up with quirky personalities like that to the point that my characters are completely ineffective, but a lot of fun to play. But in any case, he had this giant bag of dice. And my prized possession was I had dice made of asteroid. Have you seen these things? So first of all, you've seen the little tiny dice, and the people carry around the little tiny bags. You can wear them around your neck, and those are the cool kids too, right? Walking around Origins, walking around the conferences, and you have a bag of dice hanging around your head, and people just know there's something awesome in there. And these little tiny dice you can barely read, and they were made of asteroid, and they cost hundreds of dollars per die. Who does that? I won them, but still, people thought I was awesome. Okay, the punchline here. Okay, so when I first moved up here, I used to teach at Western Illinois University, and I moved up here, 2006, and which happens to be the first year where Apple announced the App Store for writing, putting software up there in the App Store. And I hadn't finished unpacking my house yet, and some students invited me to come play some Dungeons and Dragons. I couldn't find my dice. I was looking for an excuse to write an iPhone app. So like, okay, what's your first app going to be to figure out how iPhone apps work? So I decided to write a dice roller, pretty similar to what we're going to do here. And I put that dice roller up on the App Store. It's still up there today. You can go and download how many of you have iPhones? Actually, it's on Android too. It's called D20 Gaming Dice. You can find it up there. It's probably under the developer, the Michael Littman Experience or something like that. So that I spent 10 hours on that app one time. It's been up there for, I guess, 8 years now? Something like that. I have two of them. I have Gaming Dice and then Gaming Dice Pro, 99 cents and $1.99 price points. And it's insane how much money those two apps generated. Insane. I haven't touched them in 8 years, and each of those apps probably still makes me about $60 a month. And I haven't touched it. So if they're still making $60 a month, they look like crap. Go look at those apps online. They look like junk. Okay? But they're functional. They work. So from a computer science perspective, we're going to be doing the logic for that very app here. We're not going to have the graphical interface, but as you see here, the graphical interface is nothing impressive. So we're going to understand the logic it took to build something like that. You can take this skill set and turn around and start writing applications that you're going to launch on one of the app stores or through the Xbox store or something like that. You can take this skill set and you can generate serious income from this type of thing. All right, so now in the dice roller, that was timing, right? I probably had grandmothers downloading this app because, I have to get every app that's on the App Store. This is when there was like 14 apps on the App Store. So punchline is it could legitimately replace like summer jobs and jobs when you're in school. So now you can practice. You can work by practicing your programming, generating applications, then selling them on the App Store and make serious money selling those things. And $60 isn't the serious money. They did a little bit better early on. All right, so just something to kind of consider as we're going through some of this logic that we're going to write. the exact same logic. Some of it I'm going to do in class, some of it you're going to write as part of your homework assignment. And you're going to see there's nothing special about the logic. It's not difficult. It's no more difficult than what we just did with process expression. Okay? So it's not about things being difficult. It's about you having an expertise and being able to apply that to other problems. All right, so our punchline today, though, is we want to start thinking about the world in terms of objects, in terms of object-oriented programming. So I'm going to start off. We're going to go ahead and we're going to create a new class. I'm going to call this guy driver. I very often will call the class that's in my program that will have the main method in it, I'll call that my driver. Every program has a main method. I've said several times probably every program begins and ends with main. Okay, so every one of our programs will have a main method and we'll only have one of those because if it begins and ends with main, we can only have one main for it to begin and end with. Then we're going to be building players around that, building objects around that. From last semester in 200, we talked about these things in terms of actors that belong in the scene, right? The scene was kind of our main method that kind of generated, got the ball rolling. And then today, then the actual things that interacted with each other were our actors in our scene. That's going to be our objects here. All right, so I typically call this driver because this is the guy that drives the program. All right. An interesting thing you can do here, I would not recommend you do this yet until you've gotten to the point where you're very comfortable writing that main method, you know, the public static void main, string array args, blah, 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 that thing that you at any point in time can be quizzed on again, that guy. But there is a box here that says, which method stubs would you like to create? You can click on this guy and it will actually write main for you. So it'll put that guy in there. One less thing for you have to do, but I still recommend that you keep writing it yourself initially. All right, and then I almost start off every program by just printing something out, making sure nothing broke in the project when it was being generated and all that stuff. So we get our hello down here. So we can make this assumption that everything's zigging and zagging in the correct order. Okay? Now, we want to create an idea. We're going to create our first object. In our world here, we're going to create a dice object. So we want to think about that bag of dice that we have. Okay, so we have a bag of dice, and inside this bag of dice, we have a collection of various dice. We have 20-sided die, we have 10-sided die, 12-sided, 4-sided, 3-sided. Then you have all these like specialty dies, so like 3-sided. There's a 100-sided thing, which looks like one of those giant jawbreakers. Okay, those types of things. So we want to think, what is a dice object? We can call it a dice object, a die object, whatever we're going to call it. Dice makes more sense for us. Okay. So let's say dice object. Whenever we look at a single dice, okay, we pick one of those guys up. What are some things that we use to describe that dice in terms of its function? Go ahead.
It has a certain number of sides on each side.
Number of sides. Okay. So number of sides. So I pick up a D20. That is going to have 20 sides on it. And then what are the numbers that are on those sides? 1 to 20 or 0 to 19? 1 to 20. 1 to 20. So specifically number of sides, and then each side has 1 to number of sides on it. Okay? Now, we might also decide that our dice has a name. The name could even be generated. Okay, so for instance, when I pick up a D20, I've named that guy a D20. Okay, it's a 20-sided die, D20. That's kind of a common nomenclature, if you will. That makes sense? All right, so we have a number of sides and we have a name. All right. Now, when we go to the store, we're going to start off simple. We're just going to have very simple dice objects. It's not going to have any abilities yet. All he is a thing that has some attributes. All right. When we go to the store and we're buying a dice, we're going to go up to the counter. We're going to say, I need a new 20-sided dice, and I want it made of asteroid. Right? Come up short of that. Okay, I need a new 20-sided die. And they're going to have a collection of loose die that you can buy. So you're going to look at the different colors and stuff like that. But certainly from an object perspective, we can choose to keep track of color if we wanted to. But realistically, in terms of function right now, probably not important. Whether we roll a red D20 or a blue D20, we're going to get D20 type results, right? All right. So let's go ahead and let's describe our original dice object. All right. So I'm going to build another class. So up to this point, we've only had single file applications. Well, now I'm going to build a second file in here. So I'm going to right click on the default package. I'm going to say new class. And we're going to name this guy dice. Okay, and that gives me this empty class like this. All right. Now, when we create dice, the reason I started over here writing kind of our picture, if you will, these are the things we want to keep track of about our dice. We're going to keep track of the number of sides, where number of sides, each of them is going to have something on it. And then we want to keep track of the name. So there's two pieces of information, global information, that we need to keep track of about a dice object. So things that we want to remember about a dice object are called fields. Fields are variables owned by an instance of an object. That's what fields are. Specifically here, we're going to have a field called numSides, and we're going to have a field called name. numSides is an integer, so our dice class will support dice with number of sides up to 2 billion. The 2 billion sided dice, which is highly unusable. I don't think that guy would ever stop. Any of you who do dice stuff ever used a D100? They're like impossible to stop.
Oh, ours was just like a small one inside the big one. Like a small
Oh,
one.
you used percentiles. Yeah. So you sometimes D100s are represented with 2 dice. One for the tens and then one for the, so you get like a 64, something like that. But yeah, there's actually giant ones that are like, they look like almost like pool balls. And you roll that, and they have little edges, but you can't get it to stop sometimes. And you just sit there and rolls around, and you got the uneven floor. If the floor's not perfectly even, you'll find out quick. All right, and then sometimes there's even discrepancy as what number is actually up. You got to get out the ruler, put the T on it, and see what's the actual tip of the. Okay, so in any case, we're going to represent our number of sides as an integer. We're going to represent our name as a string. Right off the bat, notice I do not have static in front of those. Okay, we'll give some explanation to why here in a few minutes, but for right now, understand that we don't always need static. Sometimes we're not going to have it. All right, now let's just start off simple. We're going to use dice poorly. All right, we're going to say we're done with version 1, the crappy version of our dice object. So I'm going to come back over here to driver. This guy right here. And we're going to go ahead and we're going to create a dice object, dice D. And we'll say d.name is equal to d20. d.numSides is equal to 20. Then I can say, system.out.println d.name, and it'll print out the name of it. System.out.println d.numSides, and it'll print out the number of sides. Okay, so I've kind of built my own super variable, if you will. Just trust me on this for right now. Don't worry about the syntax. So I've kind of built my own super variable that knows how to hold 2 pieces of information instead of up to this point just one. And this guy specifically can hold two different kinds of information. I have an int and a string that he's holding. All right, so he'll print out those two different pieces of information. There's my D20 and there's my 20. Okay, and if I want, then I can create a second dice object, maybe called D2, set its name equal to D8, and set his number of sides equal to 8. And then I can print out D2's name and D2's number of sides, that kind of stuff. But now realistically, if the goal of object-oriented programming is to encapsulate, hide those details from us, we haven't done such a great job of that yet. Our main is still looking pretty busy, right? So we'd like to have some of that stuff kind of moved inside of our objects. And in order to do that, if we want to replace these three lines with a single line, what we're going to have to do is we're going to have to take advantage of this animal over here. This guy's called a constructor. Let's add this to our slide set. So we're going to call this guy a special kind of, I'm going to put method in quotes there because it technically doesn't have a return type, and we'll explain why here in a few minutes. So it's not exactly like a method, but it's a lot like a method. All right, special kind of method that has the exact same name as the class in which it is defined, and whose job is to initialize the starting state of an object in terms of initial values, etc. If you have to do any math or logging in or anything like that. Okay, so take something, we're going to build it, we're going to put all the stuff into it that it needs to be at something, and that's what the constructor does. It constructs the actual object. And this guy only gets called one time. All right, so if we're going to build the constructor for dice, his name must identically match the name of the class. He looks like a method. All right, but notice he has no return type over here. All right, similarly, constructors would never have static in front of them. Those are contradictory statements, and that'll make sense here in a few minutes. So having a constructor owned by a class does not make sense. What you will often see is the word public in front of a constructor, but it's not required in our little world here. So let's just keep it simple. So dice, we need two pieces of information. Actually, let's just say we only need one piece of information to build the dice. We need a number of sides. And from that, we could extrapolate its name. Correct? So we're going to take in an int num sides. That's what we're going to take in to build our dice. Now, before I go any farther, what I'm going to do here is I'm just going to print out num sides. So when I build a dice, whatever comes in as num sides will get printed out to the screen here. Okay, so we're actually going to be doing our printing from within the dice object, not from in main. In our little example here. And we have two fields up here that we haven't used. So understand that this num sides and this num sides are different num sides. This guy's scope is local to just this constructor. This guy's scope is local to anything inside the dice class. So this version of num sides does what's known as shadow this version of num sides. So it supersedes it. All variables boil down to their most local definitions. So when I say num sides here, he will resolve to the value of num sides that was printed here. To prove that to you, I'll just go ahead and force a -1 into our global num sides there. And then I'll make sure I don't pass a -1 in here. So we'll see that it prints out the value I passed in, not this global -1. So we'll come back out here to driver. Let's just get rid of all this stuff right now. So now I'm going to build my dice D, and this guy's going to be a new dice, and he takes in a number of sides. So I'm going to pass in 20. All right, so I'm calling upon that constructor. I'm passing it its one required value. The constructor has said, I need an integer to work. And when you pass me that integer, I will store it inside of a variable called numSize. Now we're using that variable numSize inside of that constructor. And what are we doing with it? We're printing it. Make sense? Now again, all programs begin and end with main. What does main say to do? We come in here to our first line of main. Main says create a new variable of type dice called D. Set him equal to, we'll talk about the new keyword here in a minute. Set him equal to whatever's returned by this constructor. Okay? So now we've diverted control of our program from this line over here to this class and into this constructor. So now we're running right here. Okay? This constructor will receive the 20 inside of a variable called numSize. It will then print out that 20. It'll hit the end of this constructor, which then bounces us back out here, which hits the end of that line, which hits the end of main, which hits the end of our program. Make sense? So we still started in main, then we went someplace else, then we came back. That's how programs will work. So this guy should output our 20. I passed the 20 in, the 20 arrived inside of dice, and I printed it out. Make sense? All right, so now instead of our dice object printing out number of sides, we'd like to set number of sides equal to whatever was passed in. Correct? So I'm going to take that -1 off of here. And initially I'm going to say numSize is equal to numSize. Because on the surface, that's what we want to do. We want to set numSize equal to numSize. Now, as I referenced a few minutes ago, all variables resolve to their most local definition. Well, the most local definition of numSize right here is this guy. The most local definition of numSize right here is this guy. Well, that's not the guy I actually want to set. I want to set this guy up here. All right, so beginning programmers or old school programmers who learned how to do this the wrong way sometimes would take a shortcut here. They would say, oh, no problem. I'll just rename this variable ns for numSize. And then we'll say ns is equal to, or numSize is equal to ns. So now ns boils down to its most local definition. numSize boils down to its most local definition. So we got rid of the problem by just making sure the variable names don't match, even though they hold the exact same kind of information. So realistically, we should name this variable, since we want to have our variables named with self-documenting names, names that are meaningful. We should name these two variables the same thing because they're holding the same kind of data, correct? So we need to have some mechanism for referencing this guy right here. And we do that through the this keyword. Okay, so let's go ahead and give it a definition for this first, and then we'll come back and explain it. The this keyword. This is how an object refers to itself from within itself. Make sense? All right. So this is how we refer to ourselves as me or my or I. That's kind of the equivalent to this for an object. Okay. You guys might refer to me as Mike. It would be weird if I talked to myself as Mike, right? They make jokes about, well, Mike doesn't want to do that today. You know, that's funny, right? Okay, so we refer to ourselves as I. I don't want to do that today. Kind of make sense? So this is to an object as me or my or I is to us. It's how we refer to ourselves. This is how an object refers to themselves. Now, why do we have to use this? Why do we need that kind of animal in the first place? While we're building this object out here, we refer to this object as D. Just like outwardly, you guys refer to me as Mike. Okay? You know me as that. So we reference that as, we have a variable out here called D whose scope is only inside of main. That is to say, back here, we don't know about D. Inside of this object, we are not aware of a variable called D. That makes sense? So what we really are saying is we want D's num sides. This guy that we're building right now, we want his number of sides to get equal to this guy right here. But inside of that constructor, we don't know about D. So we have to have an equivalent provided for us. And that's what the this keyword is for. And to prove that to you, after I create this variable here, I'm going to go ahead and say system.out.println D. Okay, I'm going to print out the value of D. Similarly, I'm going to go into dice. And I'm going to say system.out.println this. Let me just go ahead and take this line out. So we're still not setting any variables. What I'm trying to do is I'm trying to, actually let's do this. Inside the constructor, we're going to print out this. Inside main, we're going to print out D. Make sense? So we'll create D. What should happen is we're going to get inside the constructor first because we're going to be building it before we get back out to main where it's going to print out the value of D. So inside here, we're going to print out the string inside the constructor along with whatever this variable boils down to, whatever that resolves to. It'll resolve to some value. Out here in driver, once we're done constructing D, then we're going to print this line. The string inside main concatenated with whatever D resolves to, whatever the value of D is. Okay? Now, both of these guys, if I've advertised this correctly, will be identical values. Because D out here and this in here are synonyms. They are both talking about the same animal, the same object, the same place in memory. These guys are going to be a memory address. There's going to be a wonky looking fake memory address because Java runs on a virtual machine. Okay? So what we should see as our output here, just from order of operation, is we should see it print out inside the constructor some value, followed by inside main the same value, but retrieved from a different source. Make sense? Let's go ahead and run this. And there's our value of this inside the constructor. There's our value of D outside the constructor. So are we convinced that those are the same, referencing the same dudes? All right. So there's only one of me, whether you guys are referencing me here in the classroom or Dr. Locklear is down the hall referencing me. They're talking about the same person, the same single person. Both of these cases, we're talking about that same instance of a dice. Make sense? This falls into your top 5 list of important things that you need to grasp with object-oriented programming. This isn't a Java concept. This is an object-oriented programming concept. Every single object-oriented language you ever work in will have an equivalent to this. Java and C#, it's called this. C++, it's called this. What's it called in C? Trick question. Is C an object-oriented language? C is a procedural language. Remember, we had our picture, our hierarchy of our languages. So the transition from C to C++, where we added the idea of a class, also introduced the idea of how does an object refer to itself from within itself. Make sense? So no this or anything in C. C is not an object-oriented language. We didn't need it. Okay, so C++ is this. Java is this. C# is this. Objective-C, remember we had the branch off? Okay, we had that in this lecture set. It's from last semester, but I think we reviewed it at the beginning, right? Yeah, right here. So know this here because it's procedural. We have this here, object-oriented. This here, object-oriented. Objective-C, this is the Apple-Microsoft war. Okay, Objective-C, that language, which is an object-oriented language, instead of this, they use the word self. Self. Same thing, right? Okay. Swift also uses self. Very modern language, but kind of stuck with that lineage. Realistically, based on my definition, self is probably the more appropriate phrase or appropriate term, right? How an object refers to itself from within itself, self. This was really left over from, that's what they chose for C++, so Java, C#, both of those guys adopted that. A lot of these web languages use self as the phrase. Anybody know what Visual Basic uses as their way for an object to reference themselves? Nobody really learns Visual Basic anymore, but it is a thing. It was a rapid application development language from Microsoft for people who are kind of not programmers to kind of slap together software in a way that wasn't horrifically difficult. But Visual Basic referred to, an object referred to itself as me, keyword me, which actually is relatively appropriate, right? When you think about that, I would say that's, in the big scheme of things, maybe better than self. You know, when I'm talking about myself, I say me. I don't just say self. Well, some people might say self, but it seems a little weird, right? That's like the punchline of jokes when someone I say, you know, I said to myself, self. I don't know. Take it or leave it. Okay. But in any case, those are all synonyms to each other. Self, this, me, whatever. It's how an object talks about itself when it's inside of itself and doesn't have access to that variable that's external that has access to it. Okay? So we prove that here by printing out that value on both sides and seeing that they both are the same value. Okay? Now the important other thing we've evidenced here is, since at the very least we can all agree that if this isn't a memory address, we don't know what it is, right? This is something funky. You believe me when I say that's a memory address. Okay? And we've talked about memory addresses as multiple things kind of pointing to one place in memory. You know, at some point I've referenced this idea of a pointer. We've talked about that at some point, right? Okay? Where what we have here is we have two different ways of accessing the same exact place in memory. Okay, when we talked about the language C++, the weaknesses, when we evolved from C++ to Java, one thing we said is Java took away some of the ability of C++ programmers making bad decisions, okay, where they could choose to hand somebody the house instead of the address of the house, okay? So if I hand you D, so D exists once, I'm holding it, and I hand you that D, and you spray paint it, and then you hand it back to me, it's a spray painted dice now, right? It has definitely changed. That singleton dice has now changed because I was just passing you. I was giving you access to the exact same single object. It lives here. I told you where you can go and find it. And you just happened to go up and spray paint it. So the next time I came and checked on it, I realized that you spray painted my dice. Make sense? Same thing's true if I give you the address to my house and you spray paint my garage. When I get home, I'm going to be upset, because I have a spray painted garage. Unless you put something really cool on there, then we can talk. But, you know, punchline is that's how addresses work. As opposed to passing something by value, where I have a dice and I duplicate it. And I give you an identical dice, maybe they're both red dice. I hand you an identical one, you spray paint that, it has no impact on my original one, right? Because even though they both look the same, they are physically separate things. All right, so whenever we have memory addresses that are identical, that's two separate ways of accessing the same single thing. That means changes I make to D will have permanent changes that we can realize through this over on this side. Make sense? Similarly, I can say dice D2 is equal to D. And if I print out D2 here, we'll see that it has the exact same value as D. So I just created another variable called D2, but this guy is a pointer who just points to the exact same place that D points to. So we have two separate local variables that both point to the exact same dice in this example. Make sense? All right, so let's go back. Other advantages of using this even when you don't have to. So let's just say, well, here, as an example, with name. If I'm going to build the name here, I can say name is equal to the empty string concatenated, well, actually, we don't even have to say the empty string. We'll say the string D concatenated with num sides. Right? So if I passed in 20, this will create the string D20. I'll store that result in name. I don't have to use this here because the variable resolves to its most local definition. In the most local definition of name, the first place we'll check is right here. We don't see a definition of name there, so we'll jump up to the next scope category, which is this guy, and we see a definition of name there. Okay? Having said that, I would always recommend using this. When I say this dot, Eclipse gives me options. I can type the first couple letters of the variable name and press enter. Make sure you don't spell things wrong. All right, so it'll minimize your number of typos. On top of that, functionally, this is actually faster code. I wouldn't argue that that's a big deal to us, but this will run more quickly because by me saying this dot, I'm telling it don't even look locally. You're wasting your time. Here is the full path of where this variable lives. So I'm actually removing one step from it. But that's not the argument. The argument is reducing your errors. It's good practice to use this dot because our modern IDEs will help do code completion. Tell you what the name of the variable is and make sure you don't spell it wrong. All right, so we'll say this dot name is equal to that, so I've generated its name based on that single value of num sides. I didn't have to have them pass in the name. Similarly, I'll say this dot num sides is equal to the num sides that was passed in. That's how I differentiate between this dude up here, that is the num sides owned by me, and the num sides that was passed in to this constructor. Okay? So now I've initialized this dice object. Now externally here, I can still do system.out.println d.name, for example. And this will print out d20, the name I generated internally. All right, so I still have direct access to those variables. Now, in general, here's the problem with that. d.name is equal to Bob. And now I print out name. And even though my constructor generated d20 there, I immediately spray painted Bob on that. I've modified that dice externally. Okay, we probably don't want to allow that to happen. Okay, so that's where we have security keywords. So I'm going to cover these just real quick, and then we'll kind of learn them through practice. So we have public, private, and protected. Public means everyone has access. Private means only accessible within this class. Protected is a little bit complicated. So I'm going to give you just the surface level version of protected right now. Protected deals with something called inheritance, when we have objects that come from other objects. That's going to be something we're going to talk about here probably in a couple of weeks or something. But all right, so protected deals with that. So we're going to say only accessible within this class or children of this class. Classes that came from this class. All right, so let's leave protected at that for right now. We're not going to be using it right now, so kind of unimportant. All right, but that's at least the 65% punchline of protected. All right, now private though, these two are our go-to moves most of the time. All right, now one thing that modern technologists often avoid is, and especially programmers, is making everything public. Okay, they tend to just make everything public so we can access it. If you don't put public or something in front of it, it's what's called package level security, which means you could pretty much access it anywhere within your code, anywhere within your .java files that live inside the current package. So if you don't specify, the default is package level security, and that's this guy, this default package. You can name packages as well, but don't worry about that right now. So we have two separate objects here, and since Dice, or two separate Java files there, since Dice has two fields that don't have any sort of modifiers on them, security modifiers, they're assumed to be package level. Therefore, we can access numsides or name or this constructor, for example, anywhere inside of the default package, including over here in driver.java. Make sense? Good rule of thumb. Literally make everything private, then loosen the reins as necessary. All right. As you get better at doing this, you will be able to make your first stab at kind of the right thing. You won't just have to make it private. Okay, so the reality would be we would make these guys private. We'd also make this guy private. So these security settings, we're going to say these guys can be applied to any member of a class, where members of classes are fields, constructors, and methods. Those are the kinds of animals that make up an object. Fields, constructors, methods. Fields are our variables. Constructors are the dudes that get called one time to build our objects. Methods are the abilities that our objects have. Make sense? Okay. So let's go back here. So I made this private. I made this private. I also made this private. I made this constructor private. So I go through and ask myself the question, do I need to access the number of sides from outside the Dice class? Probably not. Do I need to access the name of it directly from outside the Dice class? Maybe not. I might have some functions that operate on those things. I might tell a dice to roll itself, and it's certainly going to roll itself in terms of the number of sides it has, right? But I don't need access to those number of sides directly. It's not part of the function of a dice. I roll the dice and a number pops up. And that number pops up, if it's a 20-sided die, it pops up between 1 and 20. Okay, I didn't need to, for our perspective, it probably helped that we knew it was a 20-sided die when we identified it. But we don't need direct access to that variable because we don't want to be able to snap our fingers and make it a 13-sided die. Make sense? We don't want to give them the ability to, when you don't put anything in front or you put public in front, you're making that variable read and write. Full access to it for anybody anywhere, let's say. Now, Our constructor, though, whole different problem. Again, private means only accessible within this class, the class that this member is private. That's a class named dice. So that means I can only call upon this guy from within the dice class. Well, I kind of need to call it from within the driver class in order to build dice. So I probably need to loosen those reins a little bit. Make sense? So we're going to go back into dice here. We're going to change this guy to public. We could leave it blank and just make it package level. The disadvantage of that is often when we're writing objects, we might be creating libraries that somebody else might use. So they might be bringing our package into their project and then wanting to use our objects within their project, which is in a different package. So making it public would then give them access to it as well. Okay? So constructors, more often than not, like most of the time, are going to be public. That isn't to say that we cannot have a private constructor, because we're going to see here in a few minutes we can have multiple constructors. We can have multiple constructors. And we can literally build one thing in terms of other things. And we'll see that here in a second. All right. So we made this public, so now this guy should be happy again here. But notice we cannot access name directly because we made that private. We can't access name directly here because we made that private. All right. So we can't write to it. We also can't read from it. So by making it private, we've cut off all access. Well, we might want to read from the name. We want to ask a dice, what is your name, for example. So that's where we go and we create something called an accessor method. So historically, so let's just call these methods. We would have something called an accessor method, which gets the value of a private member. We'd also have a mutator method, which changes the value of a private member. Typically, this would be private fields. In fact, it would only be private fields for accessors and mutators. That would be more the historical, early object-oriented language name for these things. All right. The modern name would be getter and setter. So getters are methods that get the value of a private field. Setters are methods that set the value of a private field. These guys are just names. They really have nothing to do with the syntax. All a getter and a setter is a method that happens to perform a certain task. So if I want to create a getter that allows us access to the name, read-only access to the name, I might say public string get name. And this guy would return this dot name. Make sense? Then out here in driver, I can say d dot get name. That will allow me to get the name of that dice, but I cannot change the name of that dice. There's my d20. Okay, so I've given myself read access to that. Similarly, if I want to make a setter, I would do that. So now I have a variable, or I have a method rather, that returns nothing, takes in a string, and overwrites this private field name with that string. So now I could say d dot set name to Bob. And when I print out the name now, Bob has changed. So let me ask you this. Is making a field private and then providing both a setter and getter equivalent to making a field public? Why would I ever make a field private if I intended to make a setter and a getter? If I wanted to give people read and write access to it externally, why would I ever make it private? Am I wasting my time? For most of you, your initial impression should probably be yes. You're wasting your time, right? That should be the first thing that pops to your mind, and then you should be asking yourself, okay, that's probably not what he means. Why is he wondering if I'm wasting my time? All right? The reality is that by making it private, we're at the very least giving ourselves control over how it's accessed and how it's changed. So for instance, I can come in here and I can say, if name.length is greater than 0, then I'll go ahead and let you change it. But I'm not going to let you change it to nothingness. Okay, you have to provide me with an actual name. Make sense? So now I have the ability to intercede on the changing of this value to make sure it meets certain requirements. That kind of stuff. So I can do a little bit more by making it private and then having a setter if I want to control it. Now, having said that, if we're going to literally let them change the value of something or read the value of something to whatever they want, we might as well just make it public. Why force yourself to write some functions? Make sense? But good rule of thumb, all fields should be private, and you give yourself setters and getters as necessary. That would be good programming practice. The nice thing, similar to what we talked about earlier, is there is a tool built into Eclipse. Well, actually, first let me just do this. First of all, the name of the method doesn't have to have get in it or anything. We could call this guy elephant if we want. All right? It just happens to be that elephant performs the function of getting a value of a private field. Okay? So that whole get or set isn't an important part of the syntax because a getter and a setter is nothing special. They just happen to be normal plain Jane methods that happen to do the job of a getter or a setter. Make sense? So I've written a getter here called elephant. Now, having said that, after you've practiced writing methods very often, so again, I'm going to show you a trick, but something that I don't encourage you to do until you become very comfortable writing methods. Like we've already seen, last class I kind of harped that regardless of whether you could have written the internal logic of some of those methods from last class on your own or written in a reasonable period of time, every one of you at this point should be able to write the method header. What a method returns, what its name is, and the parameters it takes to work. Whether you can make it work is a whole different argument right now. That should still be a pretty big challenge for you, for many of you at least. That you got to spend some time working through the logic, fixing bugs, that kind of stuff. But that header, that should be on autopilot now. So if you're not there yet, don't be using the shortcut I'm about to show you. Keep typing it yourself until it becomes second nature to the point where you're going to appreciate the automation. Okay? Just like the thing where it generated main before. But I have these two private fields here. So what I can do, I can right click out here and I can go down to something, the thing that says source. And then down here, there's something called generate getters and setters. I can click on that guy and it shows me my two fields, name and num sides. I can just globally make getters and setters for both of them. Or I can say, okay, well, I want to have a getter and setter for name, but only a getter for num sides. You could be specific about it. All right. Then these other things, you can make these guys, give them access modifiers, either public or protected or private or package, whatever. Usually you just leave it alone because you want to make your getters and setters public. So just hit OK, and it will write those methods for you. All right. Fairly handy when you start getting into making more complex objects that might have a whole bunch of fields up here. especially when you consider I'm an advocate of making all your fields private and then loosening the reins only if necessary. Well, now you can just give yourself quick getters to anything that somebody externally might need to have access to. Make sense? All right, so helpful little dudes here. For us right now, though, we are going to build a method that allows a dice to roll itself. All right, so this involves using a new object that we haven't used before called the random object for randomly generating values. I think I may even wrote it at some point in one of our example things. Told you don't worry about it, this just works when I was showing you variables or something. So I'm going to start down here. We're going to write a method that is called roll, takes no parameters, and this guy should return a number between 1 and number of sides for every dice. All right, kind of like rolling a dice and getting the value. Make sense? All right, so we're going to say public int, it's going to return an int, roll, takes no parameters. This is what I expect all of you to be able to write at this point trivially. Name of the method, what it returns, what it needs to work. Okay? That should be relatively second nature to you. If you're struggling with that, focus on that this weekend. And what we're going to do in here, initially I'm going to write this in kind of a poor way, and then we'll move things around and I'll explain why. But I'm going to create an instance of a class called random. And then I'm going to return r dot. Actually, let me do this. I'm going to advertise that there is a method inside of the random class called nextInt, and the method definition looks like this: int nextInt int max. So that is a method definition inside of a class called random. Is this a class method or an instance method? Never seen random before. Well, I'm showing you a method definition. This is the point of understanding how to identify these so you can read documentation. Based on what I've given you right there, this is the method definition. Is that a class method or an instance method? Instance. Why? I'm looking at the method definition, not the method being used. Why is that guy an instance method? This kind of question would also make an excellent quiz question.
Isn't it asking for the next
No, nothing to do with it. I can name this guy, Robin Yount, if I want to. No spaces, though. Not allowed. We're looking right here. What's missing? No static. Method definition, if there's not the word no keyword static there, it's an instance method. If the keyword static is there, it's a class method. Okay? How do you call instance methods? So now you've identified this as an instance method. So how do I call one of those guys? So you're aware, based on these responses, there is an extremely high likelihood of a quiz on Monday or Tuesday involving these exact questions. We call instance methods using an instance of the class in which the method was defined. We call class methods using the name of the class in which the method was defined. The string class filled with instance methods. We say s.length, s.charat, things like that, using an instance of the string class. Up to this point, our class, like hello, we've written methods and it was hello.processExpression. They were static methods, methods owned by the class. We call class methods using the name of the class in which that method was defined. We call instance methods using an instance of the class in which the method was defined. We identify class methods with the keyword static. If we see the keyword static at the method definition, it's a class method. If we don't see the keyword static, it's an instance method. Okay? Real simple. We're just keeping track of whether we see one word there. And whether or not that word is there or not tells us exactly how to call this. This guy's an instance method because the static keyword's not there. How do we call it? We call it using an instance of the class in which it was defined. It was defined inside the random class, so we call it by saying r dot next int. Okay? So r dot next int, well, before it'll let me do that, notice it's underlying random here. It's telling me random lives someplace else. It's not in the default Java stuff. So if you just hover over this real quick, it'll give you the suggestion to import java.util. So this is another library that's part of Java's default distribution that gives us access to this random object. Okay? So now I can say r dot next int, and this guy right here takes in an integer. I'm going to pass him this dot num size. Okay? This is going to boil down to a value between 0 and num size minus 1. So if num size is 20, I'll get 0 to 19. So I'm going to return this value plus 1. That make sense? So now I've taught a dice object how to roll itself. I took away those setters and getters stuff, so let's write a quick little loop for int I is equal to 0, I is less than 10, I plus plus, and let's just say system.out.println d.roll. We'll print 10 times, 10 times. So this should give me 10 numbers between 1 and 20. And run that. There's 10 random numbers between 1 and 20. Run that again. We get different numbers. Run it again. All right, so we're convinced it's giving us some random numbers. All right, now, as we've written this right now, it's fine. It works. We can call the roll method, so we've asked our instance of dice to roll itself. Similarly, I can create a second dice, dice D2. This guy can be a new dice with 6 sides. And I can say D2.roll. Now I'll get a whole bunch of numbers between 1 and 6. See kind of the power of objects? Write it generically, and then we can create multiple instances of them that maybe act a little differently. All right. Now, let's go this route. Okay, I was about to tell you about the inefficiency here. Every single time we call this roll method, every single time, we're creating a brand new instance of random. You know, it's kind of like we're every single time we want to make toast, we're going to Target and buying a new toaster. I would suggest you make random private and give it its value. You can give it up here like that, or you can give it inside the constructor. Doesn't necessarily matter. So I would probably just write it like this. So that means that this class is going to own an instance of random. We're actually going to take this even a step further next class, but for right now, this is going to be good enough. We still have access to it down here. Even though he's a private variable, we are still inside the class called dice. Make sense? All right. So, your homework assignment, and I'm going to actually go ahead and kind of start it a little bit for you. We're going to call this guy create a new class. We're going to call this guy Dice Roller. And Dice Roller is going to have a public method called roll dice. He's going to take in a dice string as a parameter. This dice string might look like 2d6 plus 3d8 minus 1d20 or something like that. Pretty similar process expression, except now what you're going to have to do is you're going to have to build out your dice chunks. Build a dice. So you'll build a d6 and roll 2 of those. You'll build a d8, roll 3 of those. You'll build a d20, roll 1 of those. And then do the math associated with it. That make sense? Okay. Now, for this assignment, just make it work for addition. So that's really all that makes sense in the big scheme of things. We would probably add subtraction if it was like 2d8 minus 3. Sometimes somebody has fire resistance or something like that. But for now, just make it work for addition. Make sense? Now, I'll give you a hint. It might be beneficial for you to add a second constructor or an alternate constructor for dice that takes in a string. You don't have to do it this way. You can pull it off using what we have here. But a second constructor that takes in a string and builds, for instance, let's say we took in 2d6. You would parse out 2d6 and create what would be equivalent to 2 6-sided dies, which would be 12-sided die. You could argue whether or not those are equivalent, but for this, that should be reasonably okay. Or you can just say, I'm going to take in the string d6, and I'll take the d off of it and just get the number of sides and use that to generate the number of sides. So you might create a different way of generating a dice. You don't have to. You can use our dice as is. You don't have to change it at all if you don't want to. And then just come in here, and when you see 2d6, you're going to generate 2 6-sided dice, roll them twice, and add it to a running total. Make sense? All right, so that's the homework for Tuesday. I will go ahead and put this. I'll actually paste our dice code into the assignment so you have that as a starting point. And then I will put this in there as your starting point for your dice roller class. So we're creating a second class. Okay? I will see everybody on Tuesday, and do expect a quiz.